Welcome back. In this session, we talk about bias, fairness, and algorithmic harm. Artificial intelligence systems are often described as objective, data-driven, and neutral. In reality, they're products of human choices about what data to collect, how to label it, what to optimize for, and where to deploy the system. Bias in AI is not an aberration. It is an emergent property of how systems are built and used. This section explores where algorithmic bias comes from, how it produces real-world harm, and why fairness is not a technical feature, but a governance challenge. What bias means in AI systems. Bias in AI does not simply mean prejudice in the human sense. It refers to systematic differences in outcomes that disadvantage certain groups or distort decisions. These differences may arise even when designers have no discriminatory intent, or models are mathematically sound, or inputs appear neutral. Bias emerges from structure, not malice. Data as a mirror of society. AI systems learn from historical data. That data reflects past decisions, existing inequalities, social norms, or institutional practices. When models learn from this data, they absorb these patterns. AI does not correct history, it reproduces it, often at scale. The problem of proxy variables. AI systems rarely use sensitive attributes directly. Instead, they rely on proxy variables. For example, zip codes may correlate with income or ethnicity. Education history may correlate with socioeconomic status. Employment gaps may reflect caregiving roles. Even when protected attributes are removed, their influence persists indirectly. This makes bias difficult to detect and harder to eliminate. Optimization creates trade-offs. Every model optimizes something: accuracy, efficiency, profit, and risk reduction. These goals shape outcomes. When optimization prioritizes overall performance, minority cases may be underrepresented. Errors affecting smaller groups may be deemed acceptable statistically, even if the impact is severe. Optimization choices are ethical choices, whether acknowledged or not. Why fairness has no single definition. Fairness is context dependent. Different definitions of fairness can conflict: equal outcomes, equal opportunity, equal error rates, or equal treatment. Improving one metric may worsen another. There is no universal technical solution. Fairness requires judgment and prioritization. Algorithmic harm is often invisible. Algorithmic harm does not always appear as dramatic failure. It may manifest as denial of opportunities, increased scrutiny, higher error rates, or reduced access to services. These harms accumulate quietly and disproportionately affect those with less power to challenge them. Visibility depends on who is looking. Why bias is hard to audit. Many AI systems operate as black boxes. Even when models are interpretable, causal relationships are complex. Biases may only appear over time, across populations, and in downstream decisions. Without deliberate monitoring, harmful patterns persist unnoticed. Bias amplification through scale. Human bias is limited by human capacity. Algorithmic bias scales. Once embedded, biased decisions can affect thousands or millions of people consistently, quickly, and with the appearance of objectivity. Automation lends legitimacy to inequality. The feedback loop problem. AI systems often influence the data they later learn from. Decisions shape outcomes. Outcomes shape data, and data shapes future decisions. This feedback loop can reinforce and amplify bias over time. Without intervention, systems become increasingly confident in flawed assumptions. Why intent does not mitigate harm? Well intentioned systems can still cause harm. Impact matters more than intent. From a governance perspective, focusing on good intentions misses the point. The question is not whether harm was intended, but whether it occurred and whether it can be prevented. Bias in financial and risk systems. In finance, biased models can influence credit access, risk scoring, fraud detection, and investment decisions. Errors here have material consequences. Because these systems are complex and opaque, affected individuals may never know why decisions were made. This raises ethical and regulatory concerns. Fairness as a governance responsibility. Fairness cannot be delegated to models alone. It requires clear objectives, defined fairness criteria, regular evaluation, human oversight, and accountability mechanisms. Governance determines whether fairness is aspirational or operational. The role of transparency and explainability. Transparency helps surface bias. Explainability allows decisions to be questioned. Neither is sufficient on its own, but both are essential. Systems that cannot be explained cannot be meaningfully governed. Why this matters for cyber and operational risk. Algorithmic harm creates reputational risk, regulatory exposure, legal liability, and loss of trust. These risks intersect with cybersecurity, data governance, and operational resilience. Bias is not just an ethics issue, it is a risk issue. The key takeaways are bias in AI systems is structural, not accidental. Fairness cannot be engineered as a feature, it must be governed as a process. Recognizing algorithmic harm requires visibility, accountability, and willingness to intervene, even when systems appear to perform well.